Guys, what we have here is this. Which question do you want me to do? Question 5, was it? Any other ones? Question 3. Okay. And 3 and 5, okay? So, what you have to do is you have to prove that it's a number squared. Any number squared is always bigger than 0. Everybody agree with that? Any number squared plus a positive number is bigger than 0. That's your job. Your job in the question is to guess something squared or something squared plus a positive number, and we'd be guaranteed that it's always bigger than 0. Is that okay? That's the goal of the question. So, the goal, what you do is you would try and reference number this if you could. But the problem is, if I reference number it, A, it won't be a perfect square. It'll end up something like this. Or B, I won't be able to reference number it. Is that alright? That's the two scenarios. So that's no good. We didn't get that perfect square we're looking for. So what we do instead is, when it doesn't reference number correctly, we look at the middle number. There we go. Okay, that's a 2. Then what's the next step then? You have the 2. Now, once again, we're trying to prove that this is bigger than or equal to 0. We've now drastically changed the question, haven't we? It's now something completely different. So, we have to multiply this out to figure out what exactly do we have. We have 1x plus 1x plus 1x plus 1. And as it turns out, we haven't actually changed the question that much. What's different? We used to have a 2, but now we have a 1. Is there any way of fixing that? Just add another 1 to the end. Okay? Now what I'm going to highlight next is the little trick here. See this here? I bring that back to, I change it back into that part there. And that part there is also known as x plus 1 squared. And now we have exactly what we're looking for. A number that's squared has to be bigger than 0, plus a number that's also bigger than 0 must result in a number that's bigger than or equal to 0. That's it. Done. Any questions on that? Okay, so question 5. Question 5, you're looking at this, and see here, yeah. Now, once again, I can't reference number that. So what's the trick? So you have to do here is x plus 6. X plus 6 by x plus 6, yeah. And then we've changed it. It's x. That when I multiply that out, it's going to turn into this here. How much am I short? So plus 4. Then after that, perfect. Why is that guaranteed to be bigger than or equal to 0? Square is always positive, plus 4 is always positive, right? Now, the next thing we're going to move on to, guys, is there's just something that you need to know here, okay? So, let me see, what would be a good way of doing this? Okay. Do you know the way x plus 1 squared, yeah? Is x plus 1 by x plus 1, which in turn is x squared plus 1, alright? Imagine I didn't have it. Imagine I used a letter instead of a number. Okay? What would happen this time? X plus a by x plus a. And the answer would be x squared ax, which is 2ax, yeah? And then the last answer would be a squared, because 1 by 1 is actually 1 and a by a is a squared. Okay, so that's what you have there. So what we're going to do next is basically, that's an example of a perfect square, isn't it? If we have another one we might want to look at is this, okay? See a plus b squared, yeah? It's the same thing, isn't it? A plus b by a plus b. But it's very similar to x plus 1 by x plus 1. It's the first one squared, 2 times the middle ones, and then square the last one. Okay? Now there's other variations of this, but what you can be guaranteed about the whole thing is that this here is always that, and the next one, which is a minus b squared, is going to be a minus b by a minus b, which is going to get me this time plus b squared when you multiply it out. Okay, what can you be guaranteed about both of them? U shape and bigger than 0. They're always bigger than 0, aren't they? Now, this full exercise is going to be completely based around this little box here. That's what they want. They want you to set that up every time. It's like a pre-planned move, you know, when you go through your phases, all to set up this move here. That's what we have to do with each and every one of these questions. We go through a couple of, we do a lot of things to maneuver our move into position, and then once we see it, we then use that trick. So, as an example, in question 7, the trick is already there for us. A squared plus 2ab plus b squared. Which one is that? It's this one here, isn't it? Which is a plus b squared. Everybody see that? A plus b by a plus b multiplies to give you this. Therefore, when we see it, they're the same number. Therefore, I can change it back into that. Okay? So we're going to get a. Is a plus b to be squared always bigger than or equal to 0? It is, because it's a squared number. Next question. Alright, they've really outdone themselves this time, alright? What's different from this question? What has question 8? How is question 8 different than question 7? There's no 0 on one side and hasn't been multiplied out yet. Yeah? So we're going to multiply it out for them. A plus b by b. It doesn't look like either one of our preset moves. It doesn't look like it. So I have to make it look exactly like it. So I work it around. Plus another ab plus b squared. Move the 4ab over to your side. Greater than or equal to 0. Still working on that move. A squared 2ab minus 4ab. Minus 2ab plus. Can I pull the trigger now on my move? Everybody see it? It's in yellow. Oh, sorry, need my yellow now. A minus. Exactly. Same thing as this one here, which is the same one as this one here. So what I do is I just go back a step, and then I do, it's a minus b. A perfect square is always bigger than or equal to 0. Right. So they try these moves a bit more. They tried on question 10 on you as well. So if you look at question 10, what they have here is this, question 10. What do you think you can do with question 10? I'd multiply out the right side and bring it over to the a squared. The reason being is I'm very used to having a, if you look at my setup, I'm very used to having a plus a squared, haven't I? I wouldn't want to give that up too easily. So what I do is I do anything to keep my plus a squared, because it's very familiar to me. It's what I know. So what I do is a squared greater than or equal to minus 2ab. What is that? 5b, is it? Minus 10b squared. Alright, this is interesting. So look at this, it's different. Okay, so we get a squared when we bring this over to your side. Okay, and then okay, greater than 0. It's not exactly what I want. Is there any way of separating it into exactly what I want? Rory? Half the middle one like you always do? Like half the 2ab and square it out? That's an idea. Can I follow? I'll do that. I'll finish this way, and then I'll come back and try it that way. Okay. So what I'd say here is that if you compare that to the one you know, it's very similar to this one here. Yeah. Except what? We usually have a b squared, but this time we have a. So I could separate 10b squared into b squared plus 9b squared. And what does that do then? Frees up our move. Do you see it? This part here. It's the original. So now I'm at a plus b to be squared plus a square number plus 9 times a squared number. Gotta be positive. I'm gonna go back to Rory had a suggestion for me, and well, I didn't actually think of it this way. I really should have. I was just thinking of it my old way. Rory was suggesting that I open up a bracket. I half the second number, which is a good call. So I'm going to do a plus b. I'm going to square it out, and I'm going to get a squared plus 2ab plus, and then I'm going to compare it to the 10b squared. I'm realizing I'm short 9b squared, and you actually more or less get the same result. You get exactly the same result. I know, that's a very good call, Roy. I'll try it again with something else in a minute if I can go. So in question 13, guys, we're going to multiply everything out, and we're going to bring everything to one side. Okay? So multiply out a plus b by a plus b. We already have it here, don't we? It's a squared plus b squared. Okay? That's that part off my list. Okay? I'm now going to multiply this one out. Minus 2ab plus 2b squared. Strike that off my list, I've done it. Greater than or equal to 2b squared 2ab. Okay, I'm going to tidy up this side for a minute. The two of them cancel, don't they? I get a cubed plus 3b squared. And then bring it over to the left side, and what do we get here? Yeah, minus. Oh, this turns out nice. A squared plus minus 2 ab plus b squared. Now I'd have that learned off by heart back in the day, because Rory might try this. Now Rory, the problem with your way, if you don't mind saying, there'll be one problem, alright? It's what Luke alluded to earlier. When you half of it, people would actually write down ab and not just b. If you can, perfect. So what Rory, once it's an x, it's grand, but you just take. Do you remember when we halved? Remember when we did this x squared minus 2x? Remember we halved the. Remember when we halved the 2? Yeah. We actually ignore the x. Yeah. So technically speaking, you ignore the a. So it's the same thing actually, but just done. So what you do is you'd ignore it like that, and you'd say it's that there. You'd square that back out, and actually this time around you'd actually realise, look, it's actually the same thing. So this one's perfect square bigger than 0. Okay guys, for homework tonight, fortunately you're going to have to go through the same ones. So we'll give you 4. This one only has different letters, so don't worry too much about it. That one there. Okay guys,